Today we're going to talk more about functions. We're going to evaluate some functions given a value. We're also going to do some compositions of functions and talk about their domains. So first, f of 8 means that we're going to take that 8 and substitute it in for the x's in f of x. So that's 4 times 8 over 8 minus 3. 4 times 8 is 32. 8 minus 3 is 5, and nothing goes into 5 and 32, so that is our simplified answer. Next is g of x squared plus 21, so that means we're going to take this x squared plus 21 and substitute it in right here for that x in g of x. So that's x squared plus 21 minus 7. Okay, so we've got a 21 and a negative 7. Those are our like terms. So that's x squared plus 21 minus 7 is 14. Next, find the value of f of x plus g of x and find the domain. So that's 4x over x minus 3 plus x minus 7. Now, in order to add these, we've got to have a common denominator. So we're going to multiply this one right here, top and bottom, by x minus 3. So now we've got a common denominator. So we can combine everything we need, all our like terms on the numerator, and put it over that denominator of x minus 3. So we've got 4x plus x squared minus 3x minus 7x plus 21 all over x minus 3. Now we'll combine our like terms. We've got an x squared, and then 4x plus negative 3x and negative 7x, which is really negative 10x right here. So 4x plus negative 10x is negative 6x. And then plus 21 over x minus 3. So when we add, subtract, multiply, or divide functions, the domain has to satisfy both of the original functions, and it has to satisfy the composition, which is what we got right here by adding them together. So up here in f of x, if I put a 3 in for x, my denominator will be 0. So here, x cannot equal 3. Here, I don't have a variable in a denominator or under a radical, so x can be all real numbers. And in my composition, if I put a 3 in the denominator, and for x, then I will have 3 minus 3, which is 0. So x cannot be 3 here either. So I've got x cannot be 3. X can be all real numbers. X cannot be 3. So the only restriction is x cannot equal 3. So that's my domain. Okay, now subtracting. 4x over x minus 3 minus x minus 7. To subtract, once again, I need a common denominator. So I need to multiply here by x minus 3 over x minus 3. So now I can subtract my numerators because I have a common denominator, so 4x minus, and we've already multiplied x minus 7 by x minus 3 right here, and we got this, x squared minus 3x minus 7x plus 21. So that's x squared minus, and then minus 3x and minus 7x is minus 10x plus 21, all over x minus 3. So we've got to make sure this negative is applied to everything. So I've got negative x squared. Then 4x minus negative 10x is plus 10x, so plus 14x. And then negative applies to that 21 also. So that's my composition by subtracting. And once again, I have to make sure my domain satisfies f of x g of x, and the composition. So x can't be 3, x can be all real numbers, and again, x can't be 3. So the only restriction is that x cannot equal 3. F of x times g of x. Now to multiply, we do not need a common denominator. So we've got 4x over x minus 3 times x minus 7. And it might be helpful just to put that over 1 so we think of this as multiplying two fractions. We multiply the numerators, then we multiply the denominators. So we've got 4x squared minus 28x. So that's just distributing that 4x onto x minus 7. And then x minus 3 times 1. So once again, f of x can't be 3, g of x, all reals, and here in this composition, x cannot be 3. So the only restriction is that x cannot be 3. And then g of x divided by f of x. So that's x minus 7. And once again, let's just put that over 1. So we're just dividing two fractions over 4x over x minus 3. So if we multiply this numerator by this denominator, this outer loop, that's going to give us a numerator. And we've already multiplied x minus 7 by x minus 3 a couple times. We got x squared minus 10x plus 21. And 4x times 1, that's my denominator. Now if we go back to f of x, we found that x cannot be 3. For g of x, it's all reals. And here, I can't put a 0 in for x because I would have 4 times 0, and that would be a denominator of 0. So there's my composition. I've found two restrictions. X cannot equal 3 or 0. Find f of g of x. Here's another way of writing that, f of g of x, which means we're doing f of x minus 7. So in function f, I need to replace the x's with x minus 7. So that's 4 times x minus 7 over x minus 7 minus 3. So I'm going to have to work toward the left here since I'm out of room. So I can distribute that 4x minus 28. And here I've got like terms, negative 7 and negative 3. That's x minus 10. The domain when you're doing a function of a function is a little bit different. We don't have to write it to satisfy all three, the two originals and the composition. We have to satisfy the inner function and the composition. So the inner function, g of x, we know has a domain of all real numbers, and the composition is all real numbers except 10. So x cannot equal 10 is the domain. Now that's a different way from how we did it in the last video, where we had a 2 to 3 step process. So we can, this is just another way, we can do f of g of x, find the domain of the inner function and the composition, and we're going to go down to number 9 and find the domain of f of g of x, which should be the same domain we just got. We're just going to do it the same way we did in the last video. The first step is the domain of the inner function. So the domain of g of x, which we already know is all real numbers. I'm circling that because I use the inner function in my domain. Step 2 is the domain of the outer function, f of x, which we already know is that x cannot equal 3. Now I don't use that in my final answer, but since this is not all reals, I continue on to a step 3, where I do the domain of the composition. And that I steal from 1 and 2. G of x cannot equal 3. So g of x is x minus 7, so x minus 7 cannot equal 3. When I move that 7 over, I get x cannot equal 10, and I circle that. I'm going to use the inner function and the composition. So the domain, and I'm going to write this one in the formal way, domain of f of g of x is the set of all x, which means all real numbers, such that x does not equal 10. It's the same answer we got right here for the domain. It's just that we've now written it in the formal notation.
Let's end this lesson with a short review on how to find the domain of a function of a function. So we've got these overlapping functions. How do we find the domain of the composition? Okay, so the first thing we're going to do is find the domain of the inner function, which is g of x. So step 1 is the domain of g of x. Okay, so g of x, if we just look at g of x, we know if I put a negative 10 right here for x, 10 plus negative 10 is going to give me a denominator of 0. So I know I cannot put negative 10 here. So I'm going to say x cannot equal negative 10. Okay? So there is the inner function. Next, we do the outer function. So the domain of f of x. Okay? So what would make this denominator equal to 0? 2 times 3 minus 6 would be 6 minus 6. So if I put a 3 here, I get a denominator of 0. So I know x cannot be 3. Okay? Now, when this step is just all reals, I can be done after 2 steps and write my domain. However, the domain here in the second step is not all reals. So I go on to a step 3, okay? So that is the domain of the composition. So what I do is I steal from step 1, g of x, from step 2, cannot be 3. So I say g of x cannot equal 3. So g of x is 3 over 10 plus x. 3 over 10 plus x cannot equal 3. Okay, now I'm going to take this denominator and multiply it over to the other side. 3 cannot equal 3 times 10 plus x. Okay, then I'll distribute. 3 cannot equal 30 plus 3x. Subtract 30, negative 27, cannot equal 3x, and divide by 3, so negative 9 cannot equal x. Okay, now my final domain uses the domain of the inner function and the composition of the functions. So my domain is the set of all x such that x does not equal negative 9 or negative 10. And I really should have written, instead of just D for domain, I should have written what it's the domain of. So the domain of f of g of x is this. So this is what my answer should really look like. Okay, number 2. Now I just switch the two functions. F of x is the inner function. Step 1, domain of the inner function, f of x. Okay, X can't be 3. 2 times 3 minus 6 would be 0. X cannot equal 3. Step 2. The domain of the outer function, g of x. 10 plus negative 10 is 0. So x cannot equal negative 10. For step 3, I steal from step 1, f of x. From step 2, cannot equal negative 10. So f of x is negative 5x over 2x minus 6. That cannot equal negative 10. So I'll multiply this over here. Negative 5x cannot equal, and I'm just going to go ahead and distribute it. Negative 10 times 2x, negative 20x. Negative 10 times negative 6, 60. Okay. Then I'll move this negative 20x over to be positive, so that's going to be 15x cannot equal 60. And divide 60 divided by 15 is 4. X cannot be 4. So for my domain, the inner function and the composition must be satisfied. So the domain of g of f of x is the set of all x such that x does not equal 3 or 4.